Is it running? All right, thank you. For those of you listening at home, welcome. We're about to pray. Join us. In nome del Patris, et Filii, et Spiritus Sancti. Amen. Sancta Michael Arcangelo, defenda nos in prego, contra nequitiam et insidias diaboli, ex depressidi, impere illi Deus, simplices et precam, tuque, princeps malitiae celestis, Satanem, aliosque spiritus malignos, qui ad perditionem animarum advogantur in mundo, divina virtute in infermum detruit. Amen. In nome del Patris, et Filii, et Spiritus Sancti. Amen. All right. If memory serves, we have, get it right on the board, sorry, but 1G is a truth. Quadratic functions and graphs. Let's see what you have. It's what? Oh! That's right. Never mind. I just gave 4 people a... Sorry if I gave you all a heart attack. Sorry. My bad. Got one more day. That's right, because I wanted to show you a couple of more other demos of graphing. Let's see if we can finish this off. I want to give you some time to work. Try this if you'd be so kind. Example. Y equals negative 2 parentheses x plus 3 parentheses squared plus 5. Go ahead and write that down. I want to put together all the stuff we had yesterday as a summary. If you can remember the pattern for a parabola, that'll help. If you can remember the 3 ways to change a graph, move, resize, flip, that'll help. And what math operations do that. And if you know how input and output behave, that'll help. Can somebody tell me anything at all about this graph? First of all, can somebody tell me what shape it is? Go.
Parabola.
It's a parabola. What tells you that?
It's a square.
Yeah, the fact that the output is squared is somewhere inside. The fact that there's a squared in the output, it's a parabola. Nate, can you tell me the pattern for a parabola, normally? Over 1 up 1? Over 2 up 4? Over 3 up 9? How about over 7? Up 49, over 13? Next, up 169, etc. However far you go over, you go up that amount squared. And somebody tell me something else that's different about this particular parabola. It is a parabola, but there are some changes compared to normal. Sam, name one change between this and just plain old y equals x squared. Five spaces higher. This, let's talk this through. The plus 5, first of all, Sam, is that a move, resize, or flip? It's a move. Why do you say that? Right. Addition and subtraction are moves. Does that make sense? Anytime you add or subtract, you move the graph. Nick, take over. You got 5 as a move. Is that input or output? The plus 5. How would you tell?
Whichever one's outside the parentheses.
Yes. If it's inside the squared, it's input. If it's outside the squared, it's output. So this case would be what? Output. Tell me, output. Is output left, right, or up, down?
It's going to go up.
Well, just in general. Is output go left, right change or up, down change? Up, down, a vertical change. Which one is it actually going to do?
It's going to go up.
Explain. Why not down?
Since it's positive, but it's an output, therefore it's like you expect it to do what it's going to do.
Yes. We expect it to go up 5. If the only 2 choices are go up 5 or down 5, we expect plus 5 to go up 5, and output does what you expect. Next. So, Megan, give me another change. Or anything that's different about this versus y equals x squared. Multiply by -2. I'm actually going to split that into two. This thing and this thing. I'll take the two. Is the times two a move, resize, or flip? Resize. Nice. How come? Yeah, it's multiply. Multiply and divide resizes a graph. Nate, take over. It resizes, is that two input or output? Output. Nice. How do you know? Yeah, it's outside the parentheses. Now, even if there's no parentheses, if it's inside the function, it's input. If it's outside the function, it's output. Does output go left, right, or up, down? Up, down. Does it do what you expect? Yes. So put this together, Katie. If it's a resize with output, up, down, and it does what you expect, ignore the negative for a second. The times two, what is it going to do to the graph? Yes. So it makes it what? Other way. It doesn't change the other. Nice. Nice. So in other words, it makes it 2 times taller. Right. The pattern, the over doesn't change, but the up does. It makes it twice as tall. Good. Are we still okay? So multiplying by 2 in the output makes the graph twice as tall. Let me see. Can somebody tell me what this is? Blake, help me out. What happens when you have a negative? Is that a move, resize, or flip? That's a flip. When you switch the sign, it's a flip. Question, is that flip on the input or the output? It's in the output because it's outside the function. An output goes left, right, or up, down? Up, down. So a flip, you don't have to worry about, times 5 or anything. Does it flip up, down, or does it flip left, right? It flips up, down because it's output. So in other words, it flips upside down. Does that make sense? There's one more change in there. Ray, help me out. This +3 is the only thing left. Is that a move, resize, or flip? Second. Move, it is. How come? Oh, because what 2 math operations move things? Exactly. Addition and subtraction. Is that in the input or the output? Second. Input. Very good. Megan, take over. If it's input, is that left, right, or up, down? It's left, right. So it's going to be a left, right move, which means it either moves left or it moves right. Mary, take over. If it's input, does it do what you expect? No. What would you expect +3 to do if you're moving left or moving right? To the right. What's it actually going to do? Correct. It moves to the left. Oh, I should have picked this one. It moves up 5. I forgot to write that. And then this moves 3 to the left. Did we clear? When you're graphing, I'm going to jot this down real fast. When you graph, do the moves first. Do the moves first. Basically, there'll be a new vertex, a new starting point. Then you can do the pattern from there. Second, note if it's upside down or not. That'll affect your pattern. If it's upside down, instead of going over 1, up 1, over 2, up 4, you go over 1, down 1, over 2, down 4. And then last, use the height multiplier. Let's try it. See if we can graph this thing. What is the starting point of any normal graph if you don't mess with anything? 0, 0. Maybe I remember the nickname of that, by the way. The origin. The origin, it's with the original point, that's 0, 0, where everything starts. So if that's true, where's our new starting point? Because it moved. Go.
Negative 3, 5.
Yeah, it moved 3 to the left. So you physically move 3 to the left, and then up 5. So it's negative 3, 5. Okay. So I'd say the vertex is negative 3, 5. Okay. What pattern do we use? So over and up is normally what you get. Over 1, up 1, over 2, up 4, over 3, up 9. What happens in this case? Okay.
You have to multiply by -2.
By -2. So tell me what changes. Did the overs change? No. Did the ups change? What did they become, by the way?
Negative. Oh.
You're right.
They come down.
They become down. So what do you get?
-2.
Yeah, down 2. You can pretend that's -2. What's the next one?
Down 8.
Down 8 and down
18.
18. You don't necessarily need to do this, but everybody please jot this down. Key points. No pun intended. So, yeah. For a parabola graph, there should be 3 points minimum. You cannot graph a parabola with less than 3 points. Does not happen. Including the vertex. I will say 5 points is better. And if you want to go nuts, you can do 7 points, 9 points, 11 points. You keep adding pairs, but you don't have to go crazy. 5 points is what I would consider a well-drawn parabola. 3 is if you're desperate. Like if you have to run out of the room because it's a fire alarm or something, then you do 3 points and then it pulls out the door. I exaggerate a little bit. But can somebody talk me through this? Where do you go? What do you do? It's really courageous. Nate. I'm up at this point, negative 3, 5. What's the first jump? What's that? One word I'd change. Over 1, down 2. So over 1, I'm going to mark this here. Over 1, down 2. Put 2 dots there. You got to go both ways. Does that make sense? So over 1, down 2. Keep going. Over 2, down what? 8. Starting from where? Vertex. You always start over from the vertex. Don't keep going. So over 2, down. You're going to go down to -3. This is 5. So over 2, down 8. Both ways. That's 5 points, and that should be more than enough. Make sure the top is curved a little bit. Don't make it pointy. And there's your problem. Nice. Now a couple questions. Can somebody spot the axis of symmetry? First of all, can somebody tell me what that is? Okay, what's the axis of symmetry, just in words? Yeah, it's a line that splits the parabola perfectly in half. Does it have one? Where? Oh. Well, this point here is -3, 5. This is -2, 3. This is -1, 3. I have absolutely no idea what these are. That was clever, by the way, going halfway between the roots. But there's something else that'll give it away. The axis of symmetry runs right over what? The vertex. How far over is that? Give me an equation for that. Is that x equals negative 3 or y equals negative 3? You just found your axis of symmetry. That entire line, x equals negative 3. Remember, x equals a number gives you a vertical line. In this case, that's the axis of symmetry. You'll be on to do that on the homework. Do remember the axis of symmetry goes straight through the vertex. So the vertex, one of the two numbers of the vertex is your answer. You just have to know which one. Either x equals negative 3 or y equals 5. So, can somebody tell me, look over here on this side, the y-intercept. Can somebody tell me how to find a y-intercept? There's a math trick to doing it. It's a mathematically sneaky way to find the. You could keep graphing, that's the long way, and you need a lot of paper. What's the sneaky way? A y-intercept, and if you don't have this, write this down when you get go.
Substitute 0 in for x.
Yeah, y-intercept is when x is 0. Always, forever and ever. If you plug in x equals 0, you will get a y-intercept, if it exists, on the graph. So where is it? Yeah. That's what it certainly looks like it'd be 5. Try it. By the way, that works for standard form. Try it. Let's try it. Let's plug it in. So y equals negative 2 parentheses 0 plus 3 parentheses squared plus 5. Go ahead and simplify it. Let's see what we actually get. Yeah, see, it's going to be a mess. So what's 0 plus 3? 3. Squared, 9 times negative 2
Negative 18.
plus 5. Almost. One word missing.
Negative.
Negative 13. The y-intercept is negative 13. If you kept graphing it, it would show up there. Guess what I'm going to ask for next. I got the y-intercepts. I want to know the x-intercepts. How many are there, first of all? Mary. How many x-intercepts does this thing have? 2. One way to do that is look at the graph. It's crashing through the x-axis twice. Unfortunately, they're not whole numbers. So I couldn't eyeball them. Is there a way to find them? Anybody? We found a y-intercept by a math trick. You find the x-intercepts by another math trick that's very similar. Set y equal to 0. Let's try it. 0 equals negative 2 parentheses x plus 3 squared plus 5. All right? Somebody talk me through that, oh, algebra people. Oh, Sam. How, by the way, what does equals 0 mean? Math people? Anybody? It means you're going to solve. Do it, Sam. How do you solve something like this? We have 4 methods of solving. Pick whichever you think will work. Algebra does work. Why? You can only do that if one species of x, which lucky you do. So you don't do the quadratic formula on this because it's not in standard form. You don't do complete the square on it because it's already completed square. You don't factor because there's nothing to factor. Algebra will work. Talk me through. What do you read at first? That's when you're plugging stuff in. When you're solving, you're like canceling stuff on both sides. So what would you cancel first? The 5. Why? It's furthest away from the x. It's kind of like peeling an onion. You peel off the outer layer first. So how do you get rid of the plus 5? Subtract 5. As long as you do it to both sides. So we now have negative 5 equals negative 2 parentheses x plus 3 squared. Is that right so far? I'm trying to get x by itself. And I need to clear off some stuff here. Does everybody have this graph stuff up here? No? Okay. You can always watch the video too. Let me clear this stuff off. So I'm going to jump up here. So we have -5 equals -2, parentheses x plus 3, parentheses squared. Take over Blaze. On x by itself. Yeah, divide by -2. Both sides. What do you get? Positive 5 over 2 equals what? X plus 3 parentheses squared. Good. Question? I know. Okay. Let me see. Mary, take over. How do you get x by itself? What do you get rid of next? I'd love to get rid of the 3. There's something further away though. The square. How do you get rid of a square? Square root. How many answers does the square root have? 2. Very good. What kind? Plus and minus. We're going to square root both sides, plus minus. Over here, the square and square root cancel. X plus 3 equals, I'm just going to leave this as plus minus square root of 5/2 just for a second. Last step. Oh, second to last step. Nick, you're on. Subtract 3. Now question, where would I put the -3? In front. When I put it here, people can't tell if it's square rooted, people can't tell if I'm plus minusing the minus. It's a lot easier to just let it butt in front. It becomes x equals -3 plus or minus the square root of 5/2. Those are your x-intercepts. I just have one problem with that. That's the correct answers, by the way. There's one teeny detail we need to fix. What's wrong? What do you think? What's wrong with just leaving it like that? Radical in the basement. Can somebody tell me how to get the radical in the basement? Austin. Radical 2 on top and bottom. What do you get? X equals -3 plus or minus what? 10 over the number 2. Congratulations. And that's probably some of the hardest roots you'd get. The only thing that might be a little more annoying is if you had imaginary roots, which sometimes happens. Those are your x-intercepts. And that's all the book is going to ask you to do. Hurry back. Blah, 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 blah. I think that may be it. You have the better part of a half hour. Enjoy, or good luck, whichever you think would be most applicable. You can do both. Good luck on the thing that's eminently enjoyable. Okay, for the people watching at home, I would like homework, I believe it was 1F as in Franklin, is that right? Or G. Oh, I didn't even write it. That explains a lot. Number 1G for Wednesday. So people listening at home, number 1G for Wednesday. I'll write it on the board here. So if you freeze frame me, homework number 1G for Wednesday, that's tomorrow. Have you ever seized my YouTube channel and they pick a particular picture for what they call the thumbnail, which is the typical. They must pick the stupidest pose I could possibly get in all 35 minutes. I mean, I could be doing dignified, 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 and the one picture they pick is. Anyway, enough rant for now. God bless you all at home. Stay safe. Get healthy. God bless you all. This is my hand waving goodbye. Bye-bye.